kids, Miss Kulkarni here. In this video, let's continue with measurements and a term which we call as precision. So let's find out what precision is and how we use it in equipment and also taking measurements. So what is precision? It is also known as reproducibility. That means if we repeat the experiment over and over again, we may get same answer, and that is called as precision. Now keep in mind one thing, that while doing that you may repeat the answer, but your results may or may not be accurate. So precision is different than accuracy. Now look carefully at these four figures. Suppose if we are doing experiment with dartboard and we have 5 darts and our goal is to hit the bullseye. Are we successful every time? No. But if you label these as A, B, C and D, you can clearly see in figure C, all those darts are in the center. That means that is accurate. And also every time that dart is hitting the center bullseye, that means we are precise. So if you use the letter P for precise and A for accuracy, you can say this one is both precise and also accurate. Look at the figure B. In this figure, every dart is at different place. That means when we repeat the experiment, we are not able to reproduce our results. That means we don't have precision. What about accuracy? We don't even have accuracy. It is not closer to where it should be. Okay, let's look at the last one, D. If you notice, all these darts are on the right side corner there. That is not where our target was. But consistently when we repeat, we end up getting same answer. So what do we have? We have precision. Do we have accuracy? We don't have accuracy because our goal was to get those darts in the center. So no accuracy, but we have precision. And look at figure A. That might be a little complicated. First of all, is it precise or not? It is not really precise. The darts are going all over places. So it is better than figure B, but still you don't have precision like which we saw in C. So I'm going to say they are not precise. What about accuracy? In algebra, in math and also in chemistry, when we consider your observations, we always take the average value. So if you take the average value of this, or if you take the geometric center of all the points, that comes exactly in the center. That means it will be still accurate. So did you realize when the observations are given to you, it may or may not be both accurate and precise. It may be, and it could be just one thing could be accurate and other thing may or may not be precise. Now how do we relate it with something common? Let's take for example, if you have boiling point for water, that's our experiment, and we know it should be 100 degrees. If you keep on getting the values 100, 101, 99, if you take the average of all that, that comes 100 or close to 100, right? There are also numbers which are close by. So I can say this is precise and also accurate. What if I'm getting consistently values 89, 90, 91? The average of all these numbers come to be 90. That is not the accurate answer. It should be close to 100. But I am consistently getting that 90, close to 90. So what do we have? We are still having precision here, but we do not have accuracy in this equation. Okay. So I hope you understood the concept of accuracy and precision. Let's take the example of equipment. and find out which one is more precise. The easiest thing to remember is equipment will have markings, graduations, and then if they are closer within particular range, that means more markings are there, that will be always more precise. So look at all these figures, and then immediately what strikes is this is a test tube and there is only one marking of 10 milliliter, no other markings. That means this must be least precise, because if we fill that halfway somewhere up to here, we will have no way to find out how much volume we have. Whereas if you compare the remaining three, we have here in the middle graduated cylinder, and that has maximum marking between the two readings. That means that is most precise. Also remember which other equipment could be considered most precise. If you remember burette and also pipette, they also have fine markings. So just for more information, these also qualify to be more precise equipments. Okay, moving on, we are going to find out when we take measurement how we use sig fig or significant figure. So every time when we have equipment, each equipment will have different level of precision. So what is most important? Significant figure, or I'm just going to write down sig fig there as an abbreviation. When we take measurement, what we need to do is we always report certain digit, whatever we are sure about, we report that, and then we add one extra digit. Now what happens when the reading is exactly coinciding with the marking? We add 0 to the reading which we get. Also you should remember the curved surface of liquid has a particular name, and what is the name? It is called as meniscus, and we always take the lower, the bottom of the meniscus for the actual reading. Alright, let's move on to some actual readings. In this example, there is a ruler and we have markings A, B, C, D, E and F, and we need to find out how we report each of this reading. If you look carefully, A is between 0.5 and 0.6. So we write down 0.5. We are sure about that reading, the certain digit, and then we need to add one extra digit for that. For that, we look over here and find out, is the marking A closer to 0.5 or 0.6? And what do we notice? It's closer to 0.5. So we go back and we write our second digit less than 5, and I'm going to estimate that as 3. So 0.53 is the answer for A. Look at B. B is between 0.7 and 0.8. Actually, it's very close to 0.8. So I'm sure about 0.7, and since it's closer to 0.8, I'm going to go with second digit number above 5, maybe even 9. How about C? C is between 1.5 and 1.6. So 1.5 we are sure about. It is closer to 1.6. So we are going to add a number more than 5. I just put 8 there, 1.58. Look at D. D is exactly coinciding with the marking. And what the marking is? It is 2.5. But we don't stop here, because remember, we have to always add one more digit, and if it coincides with the marking, what do we add? We add 0. So it's 2.50. And we can also find out the values readings for E and F. E is 3.30 because it's coinciding with 3.3. And the last one is between 3.6 and 3.7. We are sure about 3.6. Since it's closer to 3.7, let's estimate that to be 8. Alrighty. Now this is about the measurement for volume of liquid which we are transferring from two different equipment. What we have here in the first figure is a graduated cylinder. And in the second figure here we have a burette. Now look carefully. In cylinder, the readings, markings increase from bottom to top. In case of burette, it's reverse. From top to bottom, we get increase in the markings. So in order for us to find out how much liquid is transferred, what do we need? We need to find out what is the reading for each of the level, A and B. What is the reading for A here? A is between 37 and 38, but it's closer to 38. So we are sure about 37, and since it's closer to 38, let's put that as 37.9. What about B? B is exactly coinciding with 35, and in that case we also add 0. How much volume we transferred? We subtract those two values, which is 2.9 milliliter. Let's look at the burette now, and we get same way two different readings. The first reading over here, if this is A and this is B, A is exactly 15, and then since it's on the marking we put 15.0. B, the second reading, is between 18 and 19, but it's closer to 18. So let's take the number which is less than 5, 18.2. So we need to subtract both to find out how much volume was really transferred. And what do we get? 3.2 milliliters. So look at this. You were able to figure out what precision is and how we use it with equipment in chemistry experiment. So guys, I hope you enjoyed the video. I will see you in next video. Until that time, bye bye. See you later.